Hi friends, in this video we're going to talk about integer vocabulary. Sorry, not how to do something. We're just going to define some words. So what you'll need is your Unit 1 packet. Okay, make sure it says Unit 1. We are on page 3, I believe. Yep. Okay. He looks like this. Okay, so page 3, and we're going to do some integer vocab. So I'm going to be up here in this corner talking to you while I'm writing on the screen. So as always, we're going to start with an I can statement. Okay, so by the end of this video and these notes, you should feel comfortable with defining and using integer vocab. Oh no, let me move my video a bit. Okay, that's all I can fit instead of writing on top of my video. So using and defining integer vocabulary. Okay, so what is an integer? An integer is a number, well, a non-fraction number actually. So a non-fraction number that can be positive or negative. Okay, so a non-fraction number that can be positive or negative. So not fraction, not a decimal, so it can be 0, can be 1, it could be -1, -219, -3,345. Could be 379. Okay, just any number that's positive or negative, not a fraction, not a decimal. Okay, so a rational number is a number made by dividing two integers. So one integer divided by another integer is going to be a rational number, okay? So that could be a fraction, it could be a decimal, or it could be a repeating decimal. Or it can be an integer. Ooh. Okay. My handwriting will get better as I go, I promise. I'll lower this, maybe it'll help stabilize it. Okay. So I'm just gonna pick some integers to divide. Let's do 1 divided by 2. I can write that as a fraction, 1/2. And if I divided 1 divided by 2, you'd get 0.5. So this 1/2 is a rational number. The 0.5 that you get from dividing those is a rational number. You can also have a negative. So we could do -3 divided by 4 is -3/4. If I took -3 divided by 4, you would get -0.75. okay? So again, this -3/4 is a rational number. The -0.75 is also a rational number. I'll make his decimal bigger. Okay? You could also, right, let's remember our multiplication properties. Anything divided by itself is 1, okay? So, if I had -2 divided by -2, I put it in fraction form, that actually equals 1. But look, 1 is also an integer. So sometimes a rational number can also be an integer. So that's where that part comes from. An irrational number is a number that cannot be written as a fraction. So what that's going to be is it's going to be a number like a decimal that doesn't repeat. So a repeating decimal would be like 0.252525, right? You can see this pattern that 25 repeats, and it would go for forever. But an irrational number is going to be a decimal that does not repeat. So that's going to be like pi. If you've ever heard of pi, it's 3.1415926, and I'm running out of room because it goes on for forever. That's what those 3 dots at the end mean. It goes for forever, okay? But I don't see a pattern there, do you? So that's irrational. It doesn't repeat. There's no pattern I can find. Okay, additive inverse. This is the number that when added makes the sum 0. Okay, so I have one number, I'm going to add something to it. Whatever this number is going to make that equal 0. Okay, so I like to think of it in terms of money. That really helps me. So if I have $1, and then I spend that $1, so I'm minus $1, I now have $0. Just say that. Too bad. Okay, so you can see I have a positive 1 and then a negative 1 makes 0. So it's just a number and its opposite. If you'd like to add that, a number and its opposite. Okay, and it works for fractions and decimals too. So if I have -1/4, what I need to add to that to make it 0 is +1/4. Okay, and remember, every positive number has an invisible plus sign in front of it. Okay, so that's going to be 0. Or decimals. If I have, now let's do 0.9. 0.9 plus negative 0.9, it's gonna be 0, okay? And those parentheses, right, that are right there, those are just so that I know it's a negative sign and not a subtraction. Because if I put 0.9 plus minus 0.9 in my calculator, it's gonna lose its mind, right? It's just a calculator. So those parentheses, let us keep it organized and know this is a negative, not subtraction. Okay, a zero pair is like just like the additive inverse, but not as an addition problem. It's kind of more like a list. So a zero pair is a pair of numbers whose sum is 0. So like really just a number and its opposite. So I have 7 and negative 7, because positives and negatives are opposites. So a positive 7, its opposite is going to be negative 7. Or I could have negative 1/3 and positive 1/3. You could have negative 1.236 and positive 1.236. So a pair of numbers whose sum is 0. Okay, the absolute value is the distance a number is from 0 on the number line. Okay, so I'm gonna scoot you back, okay? So I'm over here. My purple calculator. Okay, that's where 0 is on my number line. I'm walking on a number line. Okay, so I'm taking 1, 2, 3 steps to get to 0. Can I take negative steps? No, I can't, right? Like I can't untake the steps, even if I go backwards. Watch. All right, so I'm starting here. I'm gonna go 1, 2, 3. I still took 3 steps. They were just facing a different direction. Okay, so that's the distance it is from 0, and it's always positive. So if you want to write that in parentheses, always positive. Let me move you back. Ooh, okay. So what that looks like on a number line, squeeze this in on the bottom with me. Okay, we have our number line. Here's 0, 1, 2, 3, 4, 5. Okay, this right side is positive, goes towards the positives. And remember that towards the left is negative. Okay? So I'm going to find the absolute value. That's what those 2 bars mean. The parallel bars mean absolute value of 4. So on my number line, I'm going to start at 4. This is 1, 2, 3, 4. Ooh, that's a chunky pen. Okay, then I'm going to count how many hops does it take to get to 0. 1, 2, 3, 4. So the absolute value of 4 is 4. What if it's a negative? Let's start at negative 3. It takes 1, 2, 3 hops to get to 0. So the absolute value of negative 3 is 3. So the absolute value is always positive. Okay guys, so that was our integer vocabulary. Next what you're going to do is practice using it and identifying those over here in your 1.1 integer vocabulary practice, which is in your handy dandy packet. Have a great day. Bye!